Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's evaluate the limit of this radical function by applying the limit laws. This can be considered as a radical function because we have a radical expression here. So if we have the limit of this function, square root of 2x squared minus x minus 1 as x approaches to 4. To illustrate the limit here and at the same time to illustrate the difference between the limit laws, we're going to show here two different steps. The first one is we're going to use the limit of the power or the root and then the other limit theorems before the actual substitution. So we'll have it like this. Since we have the square root here, we can do it like this: the square root of the limit of now, instead of a radical function, a polynomial function here. Okay, this is the point of our limit of a theorem, which talks about the root of a function. So we have here the square root, and then we separate the limit of 2x squared as x approaches 4 minus the limit of x as x approaches 4 minus the limit of 1 as x approaches 4. Then we have here to apply the power and the product for the first limit. We have the limit of 2 as x approaches to 4. Then you have here the limit of x as x approaches to 4 and your power here, right? The limit of x as x approaches to 4 minus the limit of 1 as x approaches to 4. Probably some of you are thinking, why do this and why it's very long? I'm just going to present it to you so that you could understand the idea of having a shorter method. So this would be the square root of limit of the constant is the constant itself. Limit of the identity is this value, so 4 squared. Minus the limit of the identity is the value here, 4. Limit of the constant is the constant itself. So, sorry. Okay. Let us erase this. That one. Okay. Next, you will have here the square root of, you have 2 times 16 minus 4 minus 1. You will have square root of 32. Sorry, that's 32 minus 4 minus 1. Right? 2 times 16 is 32 minus 4 minus 1. That's actually square root of 27, which can be written as 3 square root of 3 because that's 9 times 3. This is the value of this limit using these limit theorems. But of course, you can just immediately substitute. You have the square root of 2x squared minus x minus 1 as x approaches to 4. So by direct substitution here, and it's even shorter, and probably some of you are thinking to do this, you have 2 times 4 squared minus 4 minus 1. You will have here square root of 2 times 16 minus 4 minus 1, which is just the same as this here. That's again 32 minus 4 minus 1 square root of 27, which gives us 3 square root of 3 as well. So this is to illustrate and to apply the limit theorems for this given radical function. So what are you waiting for? Subscribe now!